Hi there and welcome to Penguin Learning. In this National 4 Maths lesson, we'll be going on to part 3 on our series on straight lines. In this lesson, we'll be looking at vertical and horizontal lines, and then we'll be going over the process of how we can determine the equation of any straight line, and finally we will end on a good few examples to cement our knowledge and proper understanding on straight lines. So let's get started.
Ooh la la!
In part 2 of this straight line series, we learned that a horizontal line running left to right, or a line that's parallel with the x-axis, has a gradient m of 0. And if we have a vertical line that runs up and down, or a line that's parallel with the y-axis, then the gradient is simply undefined. But now what we're going to look at is finding the equation for both horizontal and vertical lines using y equals mx plus c. So let's say that we have a horizontal line here and it crosses the y-axis when y is equal to 6, and we want to find the equation of this line as well. And the first thing that we know is a line that is horizontal or is parallel with the x-axis, its gradient or m in the general equation is always equal to 0. And what about c? Well, we know c now is the y-intercept, or the point in which the line crosses the y-axis, and we can see here that the line crosses the y-axis at y is equal to 6, so that would mean that for this equation c is equal to 6. So all we have to do now to get the equation of this line is to put these values for m and c into our general equation and see what we end up with. So if we have y is equal to m, so m is 0, so we have 0x plus 6, and we know if we have anything multiplied by 0, it's just 0, so this part here disappears, the mx disappears, and all we are left with is the 6. So the equation for this line is just simply y is equal to 6. Now, one thing that you might pick up on is, for any horizontal line, the gradient is always 0, so if that's the case, that must mean that this term in here, mx, will always be 0 as well. And that means for any horizontal line where the gradient is 0, the equation of the line would just be y is equal to c, or the point in which it crosses the y-axis. So that would mean that if we had this example now where we have a horizontal line and it crosses the y-axis when y is equal to 2, then the equation of the line would just simply be y is equal to 2. And if you think about it, it does make sense, because if we take any point across this line, regardless of what the x value is, the y value for any point on this line will always be equal to 2, because that stays constant along the entire length. So to summarise, any line that is horizontal or parallel with the x-axis running left to right, the equation is just simply y is equal to c, or y is equal to the point in which it crosses the y-axis. But let's say now we have a vertical line, or a line that runs directly up and down. Well, we already knew that the gradient m was undefined, but now if we view it on this diagram and we consider the y-intercept c, we can also see that this is also undefined, because this line here, it never crosses the y-axis because it's parallel with it. So that means that a value for c, or a value which this line crosses the y-axis, doesn't exist, because it doesn't cross the y-axis, it just directly runs straight up and down, and there's not a point that exists in which the line crosses the y-axis. So if m is undefined and c is undefined, then how do we get an equation for a line that is vertical? Well, just how like horizontal lines we could define them by the point they cross the y-axis, we can do the exact same for vertical lines at the point in which they cross the x-axis. So we can say that for any vertical line, the equation of the line is x is equal to the x-intercept. In other words, x is equal to whatever point it crosses the x-axis. So let's say we have this vertical line here and we want to find the equation of it. Well, we know here it crosses the x-axis at 2, so that would mean that the equation of this line would just simply be x is equal to 2. Or if we had this line which crosses the x-axis at 0.5, well, the equation then would just simply be x is equal to 5. And again, this also makes sense because if we imagine any point across this line, we know that regardless of the y coordinate, the x is always going to be equal to 5. So if we have this point here, this might be 5, 0, this might be 5, 2, 5, 4, 5, 6, and so on. Regardless of which point we have, the first coordinate in this line is always going to be equal to 5. So that means we can say the equation of this line is x is equal to 5. Okay, so now we're going to have a look at a few examples and try and combine all of the knowledge we've learned over the past 3 lessons on straight lines. So I've found this example off of the BBC Bite Size website, so you can either try it for yourself first or you can follow along with me. So the question asks us to find the equation of this line here, and that equation would be in the form of our general equation y is equal to mx plus c. And that would mean that the two things that we have to find out from this question to get the general equation is our gradient m and also our y-intercept c. So the first thing that I'm going to look at is calculating the gradient m first. And to do that, we have to pick out 2 points that lie on this line. And you can see that for this example we have these little boxes to help us out to try and identify what the coordinates are. So to begin, I'm going to pick this point right here, and I'm also going to pick this point here. So the first point here is point 0, 1 because it's 0 on the x-axis and 1 on the y, and this second point is 1, 3. We're moving along 1 on the x-axis and up 3 on the y-axis. And we now know that the gradient is just equal to the vertical distance divided by the horizontal distance between these 2 points. So first of all, to measure the vertical distance, that's the distance that's up and down. So if we do that and we start at the point 1, 3, we can move down 2 boxes. So that means we can say that the vertical distance is equal to 2. And the horizontal distance is the distance left to right, and we know that is just 1 box, as we can see there. So that means the horizontal distance would be 1, and that means that our gradient is equal to 2 divided by 1, which would just simply be equal to 2. Now it's worth remembering as well that for this example we have a positive gradient because the gradient is sloping up the way. But if we had a line that looked like this and it was sloping down the way, that would be negative, and that means that if we use this method to calculate the gradient, then we would have to add a minus sign on the end. You might also remember from part 2 in this series, we came up with an equation for the gradient that we can calculate, and that equation was m is equal to y2 minus y1 divided by x2 minus x1. And how we get these y2, y1, x2 and x1s is we can just label the 2 points that we have. So first of all, we have to decide which is point 1 and which is point 2. So I'm just going to say this is point 1 and this is point 2. And next thing to do is to label each of the coordinates. So we have x1 and y1, then we have x2 and y2. And now the next thing we have to do is just simply put these values into our equation. So we have y2 minus y1, which would just be 3 minus 1, divided by x2 minus x1, which would just be 1, take away 0. And if we do the math, we have 3 minus 1 is 2, and on the bottom 1 minus 0 is 1. And there we have the same answer as the last method. We get m is equal to 2. So as I said, both methods are correct, just whatever you feel more comfortable with doing. But just remember, for this one, this example here, we will always get the negative sign included within the gradient value, but for the previous method where we're just dividing the vertical by the horizontal distance, you have to check the slope of the line and check if it's positive or negative and adjust the equation yourself. So now the next thing to do is calculate where this line intercepts the y-axis or the value of c. And we can do this just by simply looking at the graph and figuring out what is the point on the y-axis where this line crosses it. And we can see here, it's this point here, 1, in which the line crosses the y-axis. So if that's the case, then we can just simply say that c is equal to 1. And now finally, because we have the value of m and c, we can put them into this equation here, y is equal to mx plus c. So that would mean we end up with y is equal, m is 2, so we have 2x plus 1. And that's the equation of this line right here. Okay, so now we're going to do one final example, and again we've been asked to find the equation of this line here. And the same steps apply before. What we want to do is find the gradient m and the point on which it crosses the y-axis c. Now this time we've already been given two coordinates for us. Here we have the point P, which is 0, minus 3, and we also have Q, which is the coordinate 7, 5. So I'm just going to write them out now. So first of all, I'm going to calculate the gradient, and this time again I'm going to use the gradient equation. So that means that I'm going to label this one 0.1 and this one 0.2, and now I'm going to label each individual part of the coordinate. So here we have x1, y1, and x2, y2, and we can say that the equation for the gradient is equal to y2 minus y1 divided by x2 minus x1. Now we know that y2, this is here's 5, so we would have 5 minus, and then y1 is minus 3. So remember, don't forget that extra minus sign, we put that in the brackets. Then that's all divided by x2, which is 7, minus x1, which is 0. So now what we have to do is simplify the top and the bottom. So if we have 5 minus minus 3, we know that if two minus signs come together, they become a positive. So that means we can write m is equal to 5 plus 3, and that's all divided by 7, because 7 minus 0 is still just 7. And then finally, we know 5 plus 3 is 8. So we can just simply say that our gradient is equal to 8 divided by 7. That can't be simplified any further, so that's good the way it is. So again, all we've done here is put these values x1, y1, x2, y2 into our gradient equation, simplified it, and then we've got the answer here of 8 divided by 7. So if our gradient is equal to 8 divided by 7, our next step is to find c, or the y-intercept. We can see here on our little diagram that this is the y-axis right here, and it's this point right here on which the line crosses the y-axis, and we can see that for that y is equal to minus 3. So that would mean that for our equation, c is equal to minus 3. So now we have the values for m and c. All we have to do now is put these values into our equation. So we have y is equal to m, so m is 8 over 7, 8 divided by 7, x, and then c is minus 3, so that is our equation for this line. Y is equal to 8 divided by 7x minus 3. So let's recap what we learned on part 3 of this straight line National 4 series. So we learned that if we have any horizontal line, the equation of that line would just be simply equal to y is equal to c, where c is the y-intercept, or the point on which the line crosses the y-axis. And we also learned that if we have a vertical line, a line that runs up and down, the equation is just simply x is equal to the point on which it crosses the x-axis, also known as the x-intercept. And then finally, we've done some examples on finding the equation of a straight line, and we could do this by first finding the gradient, and we would start this off by identifying 2 points on the line and writing down their coordinates. Then we can choose one or two methods to calculate the gradient. We could either use the equation m is equal to y2 minus y1 divided by x2 minus x1, or we could just simply do the vertical distance divided by the horizontal distance between the 2 points, and then identify the nature of the slope if it's either positive or negative, and then adjust our answer accordingly. And then finally, to find the y-intercept, or c, we can just simply look at the graph and see where the line crosses the y-axis. And now, after we have both m and c, we can substitute these values into the equation y is equal to mx plus c, and that will get us the equation of the straight line. So I hope this video has been helpful to you in your National 4 learning, and if that's been the case, make sure and give the video a like. And if you have any questions on this topic, be sure to comment down below. And if you'd like to see more content like this, make sure and subscribe to the channel, or head to the website at penguin-learning.com. Thanks again for watching, and I'll see you in the next video.